Well, the Chimera is pretty much finished. I do have some fine tuning to do, but it's ready to go. I'm going to be turning back to my airplane projects now, but I did want to leave you with some final thoughts on the Chimera 7 build. You'll notice when you come in here for the first time setup, and it has configuration, it talks about going down through all these things. I highly recommend when you get to the compass calibration portion of this that you do the compass motor compensation that I detailed in one of my later videos. It didn't really tell you to do it in here. It speaks in here of compass setup, and it says see advanced compass setup, and that it makes you think maybe that's just for advanced people. But when you get down in here, it's good stuff to read. Plus, this right here is just important to the Chimera build. You saw in my videos, if you watched it, that my motor interference, wire power interference, was over 6 times the allowable limit. I would do this procedure from now on. I will always do it before the first test flight, before the new notch filters that I learned during this build, because it's an old utility that I've found works great on my quads in the past, and I was shocked when I finally did it on this Chimera instead of during the compass setup, and found it to be so badly needed, and that the interference was so far out of line on this frame. It's because of the frame geometry. So you can't tell that during the build because you haven't got to that point yet. So I really recommend, once the motors are in, the ESC's in, flight controller, and you can do this procedure, do it now. Do it before the first flight, the test flight, the auto tune. Do it before all of that. Important. I'll show you on some videos, and I'll put some links in the description to videos on this video, the subject that I watched a guy with a little 5-inch frame where the motor wires are down near the compass GPS module in the back, and he's got problems with interference for that. That Chimera frame's just a poor design. I didn't know all this until I got through building it and stuff. I just didn't see those videos ahead of time, or I would have built this Chimera completely different. I would have put the battery ESC in 180 degrees out from where it is, and technically right now I can take it apart and take the motors off and rotate the whole system around, motors and all, 180. Bolt the motors back down, put ESC back in. The battery lead will be coming out the front then, and I can bring it out that frame between the flight camera and the high definition camera and plug it in up there. Or I can bring it out the side of the frame up there and plug it into the battery away from the back. Had I known this was a problem, there are several little fixes for it. But I just wanted to make sure this compass motor compensation, I will always do it as part of the main configuration during the compass setup right here. When I get to this portion right here, I will do it in here. Though it doesn't really say it, this frame needed it so badly, it isn't even funny. Also in this area, they kind of work through everything down through here. Flight modes, fail-safe mechanisms, everything. I don't recommend fail-safes be set up before the First flighting tuning. That's not the way I did it in my builds. If you go in and look at my builds, I set all my fail-safes up after I had done the auto tune. I don't want those fail-safes getting in the way of those first flights and auto tunes and invoking on their own, which some of them can, like the vibration, etc., etc., if it gets too bad. Because the platform's not ready to do a return to launch yet. I didn't have return to launch set up when I was doing my first hovers and trying to get my altitude hold set up so I could get to auto tune. It wasn't available then because it's not. It's really, you might be able to set it up and have a switch to even flip it yourself rather than being invoked from a failsafe, but it's not going to work. You got to get the platform put together, get the motors and ESCs on enough, and with this frame I see it's the compass motor compensation should be done first, or trying to hover this creature the way it is could be bad. Now without the return to home and stuff set up, it won't be as bad because all that compass interference is not going to cause a bad return to home because it's not ready for it yet. It really isn't. You saw I dumped mine on a first return to home check over the house because I didn't do my GPS compass calibration outdoors, and I didn't have a good one. It completed normally according to the firmware, mission planner and stuff, but it really wasn't a good compass calibration. That's when I first tried return to home. It was after I had my first good auto tune. This kind of, I think, leads people astray. So you want to get that ESC in there. You want to get the motors in there, the flight controllers, the receiver in there so that you can get the first test going. Only thing you want to do for that first test is pick it up a foot off the ground and set it right back down. You just want to know if it oscillates. And oscillations would be forward, backwards, in pitch and roll, or even in yaw. It could be just jerking right and left a little bit on you. No telling from the basic firmware. It's going to be close. But they can't set the firmware to fit every frame and every motor prop combination. It's impossible. So for first flight, you should pick it up a foot. If it oscillates, set it right back down. Do what they say and change those PIDs down to 50%. Pick it up again. If it doesn't oscillate, still set it right back down. You're finished. You're ready to test altitude hold. So now that you're ready to test altitude holds, you do want to get it a little higher than a foot. You want to get it up about 8 to 10 feet. I wouldn't go any higher than that. You can't be in goggles for that. That has to be line of sight, because if you're in goggles, it's going to get way higher than you think it is in a heartbeat, and it's just not going to work for you, honest. So this is all line of sight. I face the platform away from me when I do that. So right is right, left is left, forward is forward, back is back. Pick it up about, I think, 6 to 10 feet, no more than 10 feet ever. And in stabilized mode, and flip it into altitude hold. Put your throttle to the 50% mark on your radio. The new firmware has some hover learning that I'm still getting used to. But you want to be able to hover no more than 10 feet tall in altitude hold. Big field would help, because you may have to chase it around a little bit when it's drifting horizontally. But as long as it's not drifting up and down, you're ready to set it right back down and set up auto tune. Then you pop it up, put it in altitude hold about 6 to 10 feet off the ground, flip it into auto tune and let the auto tune complete. At that point, you do have a fairly flyable platform when you have the auto tune. You don't before that. You can't do things before that. You can seem to get away with them, You might even be able to fly a autonomous mission. But based on the wind that day, based on other factors, going into return to launch maybe, uh, it'll seem to perform well, but on a different day with different wind, it can get totally out of control, get too much vibration going on, and just fly off someplace on its own, it seems. Now, I'm not too sure about these steps, especially talking. I did not set up fail safes at this point in the build. I didn't even set them up when I came down in here and was in the process of tuning. I set them up after all of this was finished. But what else? Compass motor compensation is extremely important, at least to do the check and see what kind of interference you have before first flight, in my humble opinion. And that's about all I have on my final thoughts on the Chimera. I will be doing some deeper tuning stuff with doing some first flights, more first flights, and checking vibration levels and tuning accuracy, compass and GPS accuracy, etc. But I now have a platform that is flyable. It will pretty much do what I tell it without flying off to the moon. It's very. So I am ready for my first goggles and monitor to monitor the flight video out of my Chimera. It's now ready for that for the first time, and it'll also be my first time doing those things with any platform, so that's going to be pretty cool coming up. So I'm going to publish this, and then I'm going to swing back to finishing up that second Skyhunter with the landing gear. And the Chimera's just going to be fill in on days when I can fly and do its check flights and stuff. And I'm going to turn my majority of my attention back to airplanes, because I conquered rovers early in 2016. No, probably back 2012. Conquered quadcopters in 2013 or 14, but I didn't start airplanes until 2 years ago, and just started flying them in 2022. Not very much flying going on in 2022, but I did get it started. But this year's supposed to be my good year for finishing up my Ardu pilot. Everything I wanted to try on it. And I'm itching to branch out into other firmwares, but I wanted to get Ardu pilots, rover, copter, and airplane firmwares under my belt firmly first. And I do want to do an Ardu tracker for a antenna tracker, but I don't really consider that the main firmware for Ardu. Don't really consider the boat. I do want to do a boat. I do want to do a submarine, but I don't consider them the main firmwares for Ardu Pilot. I guess I should consider boat and copter a little more. They are autonomous platforms. I guess the Ardu tractor, after fashion, is an autonomous platform while it hunts around, but not like the other firmwares to me. Okay, guys. Thank you.